In this episode, we take a step back from individual techniques and focus on how real data work becomes a repeatable, trustworthy lifecycle instead of a one-time project that works only on someone's laptop. When beginners first build models or dashboards, it can feel like the main challenge is getting the math right, but most failures happen because the work cannot be operated safely over time. In cloud security and cybersecurity settings, this is even more important because the environment changes constantly, data pipelines evolve, and decisions based on models can affect access, investigations, and risk exposure. Operationalizing the lifecycle means you create a structured way to move from business questions to data, from data to models, and from models to monitored outputs, while preserving accountability at every step. Two frameworks, Cross-Industry Standard Process for Data Mining, CRISP, DM, and Data Management Association, DAMA, help you think about that structure from different angles. We will connect those frameworks to versioning, documentation, and testing so the whole system remains reliable when reality shifts. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is to understand why lifecycle thinking exists at all, because it is not about bureaucracy, it is about reducing repeat failures. Data projects often begin with excitement and end with confusion because the team discovers late that the data is incomplete, the labels are unreliable, or the model cannot be maintained. In cloud security work, the stakes are higher because a model that quietly degrades can create a flood of false alarms, or, worse, a false sense of safety. Lifecycle thinking forces you to plan for the fact that data sources will change, that business requirements will shift, and that systems need ongoing monitoring and updates. It also forces you to separate experimental learning from production behavior, so a promising prototype is not mistaken for a finished system. Beginners sometimes think a lifecycle is only needed for big teams, but even solo projects benefit because the lifecycle is how you remember what you did and why you did it. When you can trace decisions from goal to implementation, you gain control over outcomes instead of hoping the system continues to behave. That control is what makes data work trustworthy in operational security environments. CRISP DM is a lifecycle framework that is especially helpful for beginners because it organizes the work around iterative phases that match how real projects unfold. It begins with business understanding, which is where you clarify the decision you are trying to improve, the constraints you must respect, and the success criteria you will use. It then moves into data understanding, where you explore what data exists, what it means, and what quality issues could distort results. Next comes data preparation, which is where wrangling and cleaning take place, and this phase often consumes more time than newcomers expect because it is where messy reality is confronted. Modeling follows, but CRISP DM treats modeling as one phase among many, not as the whole story, and that emphasis is important. Then you evaluate, meaning you check whether the model actually meets the business success criteria and behaves sensibly under realistic conditions. Finally, you deploy, which in modern terms includes not just launching a model, but monitoring it, updating it, and managing it as part of a system. One of the most important lessons in CRISP DM is that the process is not linear, even though it is described in phases. You often discover during modeling that the data preparation choices were wrong, or you discover during evaluation that the business understanding was incomplete. The framework's value is that it gives you permission and structure to loop back without feeling like you failed, because learning what is wrong is part of the work. In cloud security, loops are normal because the definition of risk can evolve and because new services can introduce new patterns of normal behavior. A lifecycle that allows iteration prevents teams from locking into a brittle plan too early. Beginners sometimes get attached to a model they built and then try to force the business to match the model, which is backward and creates fragile systems. CRISP DM helps you keep the model in service of the decision rather than the decision in service of the model. This makes it easier to adjust thresholds, features, or even modeling approaches when operational reality demands change. The life cycle becomes a steady rhythm rather than a chaotic scramble. DAMA approaches life cycle thinking from the perspective of data management as a discipline, emphasizing governance, stewardship, and long-term control over data assets. Where CRISP, DM is often used to guide analytics and modeling projects. DAMA helps you think about the broader ecosystem that makes those projects sustainable. It highlights the importance of data architecture, data quality management, metadata management, and security, all of which are critical in cloud environments where data is distributed and access must be controlled. For cybersecurity work, DAMA-style thinking is especially relevant because datasets often include sensitive signals and must be handled with clear ownership and auditability. Beginners sometimes assume they can use any data they can access, but a mature organization requires a clear story about who owns the data, what it is allowed to be used for, and how it is protected. DAMA pushes you to treat data as a product with lifecycle responsibilities, not as a temporary input to a model. When you combine CRISP, DM with DAMA, you get both project execution discipline and long-term operational discipline. Operationalizing the lifecycle becomes much easier when you see that these frameworks complement each other rather than competing. CRISP, DM gives you an iterative project path from question to deployment, and DAMA, it gives you the governance and data stewardship practices that keep inputs consistent and controlled across many projects. In cloud security, this combination prevents common breakdowns like having a model that depends on a dataset that later changes schema without warning. It also prevents the problem of different teams building conflicting versions of the same truth because they each wrangled data differently without shared standards. When governance and lifecycle are aligned, definitions become shared, data quality expectations become measurable, and access controls become consistent. Beginners often think governance slows innovation, but in reality, it prevents wasted work by keeping datasets stable enough to trust. It also makes incident response easier because teams can trace what data was used for what decisions and when. A disciplined lifecycle is not a constraint on learning. It is a constraint on confusion. Versioning is one of the most practical tools for turning lifecycle theory into operational reality because it gives you a way to track change rather than being surprised by it. In data work, you need to version more than code because data definitions, feature engineering rules, label definitions, and even evaluation datasets can change. If you change a data cleaning rule and do not track it, your model outputs may shift and nobody will know whether the shift reflects a real security change or a pipeline change. Versioning creates a historical record that lets you reproduce results, compare old and new behaviors, and roll back when a change causes harm. In cloud security systems, rollback is not just convenience, because a sudden increase in false alerts can create operational overload that looks like an attack surge. Versioning also helps you manage drift responsibly, because you can update a model and still keep the previous version available while you validate the new one. Beginners sometimes treat versioning as optional until something breaks, but it is far cheaper to version early than to reconstruct history later. The lifecycle becomes auditable when versions exist. It is also important to understand what versioning should mean at the level of datasets and features, because a version label is only useful if it reflects meaningful change. A dataset version might represent a new schema, a new parsing rule, a new deduplication policy, or a change in the refresh cadence, and each of those changes can alter what downstream models learn. Feature versions matter because a feature name can stay the same while its definition changes, such as switching from counting events per hour to counting per day. In security analytics, that shift can change thresholds and risk scoring behavior in ways that confuse stakeholders if it is not tracked. Label versions matter because ground truth definitions evolve, and a model trained under one definition may be judged unfairly under a later definition. A professional approach is to treat definitions as artifacts that are versioned alongside code and data, so the entire pipeline has traceability. That traceability is how you answer questions like, why did alert volume double on a certain date? Without it, you are left guessing and arguing instead of diagnosing. Versioning turns change into something you can manage deliberately. Documentation is the companion to versioning because versions tell you that something changed, but documentation tells you what changed and why. Beginners often imagine documentation as writing a long report after the work is done, but operational documentation is more like a set of clear notes that support decision-making and accountability over time. Good documentation captures the business objective, the scope, the data sources, the main assumptions, and the known limitations, because those are the things future maintainers need to understand before they touch the system. In cloud security, documentation also supports governance by explaining how sensitive data is handled, who has access, and what retention rules apply. Documentation should also describe how to interpret outputs, such as what a risk score means and what it does not mean, so stakeholders do not treat a model as a definitive authority. Beginners sometimes think documentation is only for other people, but it is also for your future self when you return to a project months later. When a system drifts, documentation helps you determine whether drift is expected, acceptable, or dangerous. A professional lifecycle treats documentation as part of the product, not as a separate chore. The most useful documentation for operational systems is typically concise, concrete, and aligned with how the system is used. That means describing data fields in terms of their semantics, not just their names, and describing transformations in terms of their intent, not just their mechanics. It also means documenting the evaluation approach, including which datasets were used for testing and what success criteria were chosen, because those choices shape how performance claims should be interpreted. In security settings, documentation can also include escalation logic, such as what happens when model outputs disagree with analyst judgment, and how disputes are resolved. Another important part is documenting monitoring signals, such as which metrics indicate pipeline health, which metrics indicate drift, and what actions are taken when thresholds are crossed. Beginners often leave monitoring undocumented, which causes slow response when issues arise because nobody knows what normal looks like. Good documentation also reduces the chance of misuse, because it makes it clear what the system was designed for and where it is not safe to apply it. This is especially important when models are reused across environments, because a model trained in one cloud workload can behave very differently in another. Documentation preserves intent, which is the heart of safe operations. Testing is the third pillar that turns lifecycle intent into reliable behavior, and it should be understood as testing the data system, not just the model. Many beginners think testing means checking whether the code runs, but operational testing also includes verifying that data arrives on time, that schemas match expectations, and that key fields remain within plausible ranges. In cloud security, a parsing change that turns an action field into null values can quietly break detection logic, and without tests the system may continue running while producing meaningless outputs. Testing also includes validating that joins and deduplication rules behave as intended, because a many-to-many join mistake can inflate counts and create a false narrative of suspicious activity. Model tests can include sanity checks that confirm outputs remain within expected bounds, and they can include stability checks that look for sudden shifts in score distributions that do not align with known operational changes. Beginners sometimes resist testing because it feels like slowing down, but testing is what prevents you from deploying errors into a system that affects security operations. In a lifecycle mindset, tests are not a luxury, they are guardrails. Guardrails are what allow iteration without fear. Another important testing concept is that you need tests at multiple levels because failures can originate in many places. Data validation tests check the shape and meaning of input data, such as whether required columns are present, whether identifiers remain unique where they should, and whether timestamps are within plausible bounds. Transformation tests check that standardization rules still map categories correctly and that regex-based extraction is not suddenly failing due to upstream format changes. Feature tests check that derived metrics remain reasonable, such as whether event rates and averages fall within historical ranges for comparable populations. Model tests check that the model still produces outputs, that the outputs are not collapsing to a constant, and that performance on holdout datasets remains within acceptable limits. In cloud security, you also want tests that protect privacy and compliance, such as verifying that restricted fields do not leak into downstream tables meant for broader access. Beginners can think of these tests as early warning sensors because they tell you the system is drifting before stakeholders notice damage. When tests are treated as part of the lifecycle, changes become safer to make. The system becomes resilient because it can detect its own failure modes. Operationalizing the lifecycle also means planning for change management, because in real organizations, changes are constant, not exceptional. New data sources are added, old ones are deprecated, schemas evolve, and business questions shift, and each change can ripple through your models and metrics. A disciplined lifecycle uses versioning to capture change, documentation to explain change, and testing to detect harmful change early. In cloud security, change management is especially critical because security controls, identity systems, and logging policies are frequently updated, and models that depend on those signals must adapt. Beginners sometimes treat change as a disruption that should be avoided, but change is inevitable, so the better goal is to make change safe. Safe change also requires clear ownership, meaning someone is responsible for approving updates and for responding when monitoring signals show issues. Ownership prevents the common problem where everyone assumes someone else will fix a broken pipeline, leading to long periods of silent failure. A life cycle that includes ownership, monitoring, and rollback turns operational reality into a managed process. That is the difference between a prototype and a reliable system. As these lifecycle practices mature, they also improve the honesty of your performance claims, which is one of the most important outcomes for responsible AI. When you have versioned datasets and documented definitions, you can say exactly what the model was trained on and what it is expected to handle. When you have tests and monitoring, you can detect when the environment shifts and performance claims are no longer valid. When you follow a structured framework like CRISP/DM, you can show how evaluation was tied to business objectives rather than to a random metric that looks impressive. When you apply DAMA-style governance, you can show that data handling respects privacy, access control, and quality standards that are necessary in cloud security work. Beginners sometimes think operational discipline is separate from modeling skill, but operational discipline is what makes modeling skill valuable. Without it, a good model becomes a one-time demo that cannot be trusted. With it, even modest models can deliver lasting value because they remain stable and accountable. The life cycle is how you earn trust over time. Bringing everything together, operationalizing the life cycle means adopting a structured way to build, deploy, and maintain data-driven systems so they remain trustworthy in changing cloud environments. CRISP/DM provides an iterative path that keeps business understanding, data preparation, modeling, evaluation, and deployment connected rather than fragmented. DAMA provides a governance and data management perspective that ensures data assets are controlled, documented, and protected as long-lived resources rather than temporary inputs. Versioning makes change traceable and reversible, documentation preserves intent and makes outputs interpretable, and testing turns assumptions into guardrails that prevent silent failure. When these practices work together, you avoid the most common disasters in data and AI projects, such as models that degrade unnoticed, metrics that drift without explanation, and systems that cannot be audited when decisions are questioned. In cybersecurity and cloud security work, this disciplined life cycle is not optional because the environment evolves and the consequences of error can be significant. Mastering this mindset is how you move from building models to building systems that deserve to be used.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.